In this screencast, 3 tools of the trade when we are proving things in transformational ways. 3 tools of the trade. One is the side switching theorem. If you have an angle and we reflect either side of the angle over the line containing the angle bisector. So there's the angle bisector. If you reflect either side of that angle over the angle bisector, its image is the other side of the angle. This is because a reflection is an isometry, and isometries preserve angle measure. So we pick any point on the angle bisector, we pick the vertex of the angle, we pick any point on the ray that we're reflecting. We know that angle AVP must be congruent to angle A prime V prime P prime. So we know that V prime is V, and we know that P prime is P because they are on the line of reflection. So we know that A prime must be on the other ray. A prime is somewhere on there. And if A prime is somewhere on VB, then that's all we need. The image of this side of the angle is this side of the angle. Warning here. All we know is that this ray becomes that one. We don't know where A prime is along there. I mean, ruler postulate will tell us, but we can't just place A prime wherever we like. We know that this ray becomes that one, and that's all we know here. Ratchet things up a notch. If you have an isosceles triangle where AB is congruent to AC, then the line containing the bisector of the vertex angle is a symmetry line for the triangle. Well, why does that make sense? Well, we know that this is the angle bisector, so we know that when we reflect segment AB, when we reflect ray AB in the angle bisector, the image is ray AC. So this ray becomes this ray, which means that the image of B is somewhere on ray AC. Well, where does it have to be? Well, we know that segment AB is congruent to segment AC, so by the ruler postulate, there's only one point along this ray that generates the same distance that we had before, and that has to be here. And similarly, if we were to reflect ray AC over the angle bisector, C prime would have to fall on B. At point D where they intersect. So this becomes that symmetry. How do we know that this becomes that? By collinearity, actually. We know that C and D and B are collinear before the reflection, so B prime and D prime and C prime are collinear after the reflection, so this segment ends up there and this segment ends up here. So we know that the line containing the bisector of a vertex angle of an isosceles triangle is a symmetry line for the triangle. We also know that kites have symmetry, right? Kites have symmetry, so this is a kite. Those are congruent. Those are congruent. The line containing the ends of a kite is a symmetry line for the kite. We just use the isosceles triangle symmetry theorem twice, and it gets us exactly what we want because this line has to be the angle bisector for both of those isosceles triangles. And so we're done. So those are just some things to look for. They may be helpful to you as you're doing transformation-based proofs. Okay, very good.